So a histogram is a graphical representation of quantitative data showing the response values on the x-axis and the frequencies on the y-axis. Now, the responses are grouped into bins. All right, the responses are grouped into bins. These bins can be adjusted as the data needs. Ideally, there are 6 to 10 bins, but could be more or less if shape able to be identified. One more thing and I'll take a break so you can write this. Note, your solution may have a different bin width but still be 100% correct. For this homework, at the end of this lesson today, I will tell you what are the bin widths that I used in my problems. Okay, so I'll tell you where I'll tell you what my minimum value that I used, and I'll tell you what my bin width is, so that you can match yours exactly to mine. But what I want as you're writing this information down here, a couple of pieces. Okay, so when we want to see shape of quantitative variable data, oftentimes the histogram is one of the best ways to see shape. Okay, so yesterday's problems I gave you histograms. Now I didn't draw the histograms; those are all sketches of the histogram. They were sketches because it did not explicitly label the x and y axes. What the values were. It didn't tell you what the frequencies were. It didn't tell you what the response values were. It was also technically a bad histogram because I didn't give you the context in the histogram. I didn't say what the variables were in the histogram. But that was just more of, I wanted you to see a shape and be able to identify, modal, symmetric, skewed left, skewed right, bimodal, outliers. So we can view outliers in a histogram, potential outliers. I want to make sure we say that. We can view potential outliers in a histogram. We can identify shape. Now, when we make a histogram, we have things called bin widths. So, like for example, one in the response, somebody responds like 1, like how many siblings do you have? And they say 1, and somebody else says 2. Well, I might group both of those together if a lot of the responses really branch out. So I might say all of the 1s and the 2s go into the same bin. So when I see like 5 as the frequency, you don't know technically how many 1s or how many 2s there were in the responses, but you know that there were 5 in total of students who responded 1 or 2. Now, as such, histograms typically do not show individual data. So what I mean by that is that we, like I just said, we don't know if they responded 1 or 2. We just know that they are in a window. They are in a bin. And finally, if a response lands right on the line, it counts to the right bin. In other words, every bin should be greater than or equal to A, but less than B. So if the response was 1, that response so when I see a histogram that looks like this, right? Or when I look at this, this means that there were 5 responses between 1 and 1.9999999. And in this case, there was 2 responses sorry, that little, I keep hitting that little magnifying glass and then it kind of like goes, 2 responses between 2 and 3, not including. So this parentheses means not including. But the biggest mistake I typically get from students when they're reading or making a histogram is that they don't count the responses into the correct bin, or when identifying the responses and going the other way, they think that it counts for one of them when it doesn't. So I'll give you a little bit of time to write kind of this information down. What questions do you have about what I've written? I know there's a lot of words here. I'm trying to just explain, and we're going to do these in practice right now. But is there any, like, what do I mean by this? Is there any, like I said, once I do them in an example, it'll probably make a little bit more sense. But I want to make sure we have these answers and questions done first.
What did you mean by the 1 and 1.999? Like, that's where I'm kind of confused on.
So if the responses were something like how many siblings you have, and there's only integer answers, which means like 1 or 2 or 3, you can't answer decimals, then basically it just means that all of the responses with 1 go to the bin to the right of 1. But if there are decimal answers, like how much money do you have in your pocket? And someone says, I have $1, and somebody else says, I have $1.50, and someone else says, I have $1.99. Well, all of those responses will go into the bin between the 1 and the 2. So any response between 1 and 1.9999999 ... would go into that bin. But when someone says, I have $2, that $2 would go into the next bin to the right of the 2. A lot of times people will try to write the 1 underneath the bin of right there, and it'll say all the ones, and this is it. Now that is proper and okay to do only if each bin represents the response of a single value, and only if all the responses can only be single values. If not, the traditional way we draw a histogram is just like I've shown you right here. The numbers go underneath the line. Okay. Let's do an example. And I really got to I keep forgetting that I want to do a poll for your homework so that I can use that data. And I keep forgetting that I need to gather those polls. But I'll try to get the data from the class. I'll use my my old class data for the next example. We're going to go on. So example. So we are going to talk about the heights of AP Stat students in inches. So if we were in class at this point in time, I would have said, hey, grab one of my big long rulers and measure each other in terms of how many inches tall you are. So that's what we kind of we would have measured everybody in the class. Fortunately, it's coming to something that we can't do right here. Now, let's say that these were the responses I got, and I'm going to do mine as a frequency. Okay, so this is the height, and this is the frequency, and the heights are going to go from 55. Next thing we have is 60. We have a little shorty at 55, 60, 61, 63, 65, 67, 68, 70, 71, 74, and 80. We have somebody that's really tall. Really tall. Now, how many is that? Is that too tall? It's almost 7 foot tall. We have somebody really tall in the class. Okay. There's going to be 1. There's going to be 3, 4, 7, 2, 3, 3, 2, 2, 1, and 1. Now, I could have given you the data like 55, 60, 60, 60, 61, 61. And I could have given you the data like that, but I decided to give you the data like in a frequency chart. Okay? So this is the data that I have. Now, the first question that we need to ask ourselves is, what bin widths should I use? And then the second question is, what is my X min and X max I should use? Now, we will eventually have graphing technology that will help us in determining this information. And like I said, I'll tell you what I choose for my X min, and I will tell you what I choose for the bin width. Based on those information, you should be able to determine what the X max is in terms of how your numbering line should go. What should we go by? So when we make a histogram, when we make our histogram, okay, like this, these are going to be the heights and the bottom, and these are going to be in inches, and these are going to be the frequencies on the side. All right. What do you think I should go by? So I'm going to have markers here, like here, 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 here. What should I go by? And what should I start with? And we're looking at the heights. We're looking at the heights.
Just start at 1.
No, we definitely don't want to start at 1.
I have a question. Can we start from 50?
Yeah.
Is that like
Yeah. And so we can actually put a little bracket here, a little squiggly mark right there, and we can start at 50, or we can start at 55 if we want to. I would probably start at 55. But let's say we wanted to start at 50. That's fine. Okay. And what are we going to go by? Fives. Going by 5. So I'm going to use a bin width equal to 5, and I'm going to use an x min of 50. I could have done 55 as well. I probably would have went with 55. And the reason why I'm going to go by bin width of 5 is because, like I said, I want like somewhere around 5, 6, 7 bins. That's typically what I want. It seems most of my data is between like 55 and 70-ish. You know, so that's only like 4 bins, but I think but it goes all the way to 80. So 5 feels good. If you went by 4s, would that be wrong?
No, it would just be too detailed.
Well, it might be too detailed. It might be just as appropriate as going by 5s. It's just almost a matter of preference. If you went by 4s, if you went by 3s, I maybe 3s might be a little too much. But if you went by 4s or 5s, I think that would be more than ideal for this problem. So you had a choice here. And if you chose by 3s, 4s, or 5s, you'd probably be able to see the shape. Like I said, how do you know? It's practice. You look and see how far your minimum and your maximum are for each other. They're like 25 apart, right? It's like 25 apart. So I probably want to go by 5s. That seems around right? 25 divided by 5 is 5. Seems to be about right. If you want to go by 4s, that's going to be good as well. So 50, 55, 60, 65. How far do I got to go? 70. And be careful in your response. How far do I have to go?
Up to 80.
Be careful.
85.
85. You have to go to 85. Why? Can anybody tell me why? I could have gone to 90, but 85 is what I need to go to at least. Why does it need to go to 85? Why do I need that 85 on my bottom, or else my histogram will be incomplete?
Does it have anything with your bin width?
Not necessarily the bin width. Look at the responses. Look at their heights. It has to do with one of the heights. What's the maximum height?
80.
80. And where is that bin going to go? Where is that going to go into?
Or in between 80 and 85.
Between 80 and 85. So most people think that because my last number is 80, I just go up to 80. But that 80, and that's the big trick right there, has to go into the next bin. All right. Now, in making my heights now, my frequencies, this one's a little bit trickier. So if I'm going by, I kind of have to add them up and kind of see. If I'm going by 5s, this one goes in its own bin, which has 1. 60 through what goes into the next bin? So this first bin is going to be a height of 1. This bin right here, there's only going to be 1 that's going to go in here from this one right here. How many are going to go into my next bin? 60 through 63, okay, and how many is that?
14.
Good. Then 65 through 68, how many is that?
8.
It's 8. And then 70 through 74, how many is that?
5.
And the last one has its own bin of 1. All right, so of my bins, of the ones I'm grouping together, what is the biggest frequency? What is the highest number?
The 14 one?
14, which means that I have to go up to what on my frequency, on my y-axis?
Up to 20 or 14?
I have to go to at least, I got to go to 14. So my y max, my next question is that because of this is what I refer to as my y max, 14. So I got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I have to go by ones? Did I have to go by one? No, I could have gone by.
So
I could have gone by twos. A lot of people will think, well, I went on by fives on my x, so don't I have to go by fives on my y? The answer is no. And then there's the other question, can I start at 50? And the answer is yes. If we add that little brace right there, we would only do it on the x-axis so that we don't start at 0. We definitely don't want to start at 0 since my first data point is actually 55. And like I said, in this data, I would have actually started at 55 if I was doing it. But I just want to show you that starting at 50 is perfectly fine. All right, now let's make our histogram. That first bin, what do I go up to in my first bin? My first bin is 50 to 55. What do I go up to in that first bin? How many do I have in there?
just one.
No. There's none between 50 and 55. Remember, we got to be careful. The 55 one goes to the bin to the right. So this is the reason why if you I put it here so that you got to be careful about that. The first one doesn't start between 55 to 60. So this one right here is for my 55 to 60 bin. Then this one right here is my 60 to 65 bin. Okay, so my first bin doesn't start into 55, and so that's going to go to 1 right there. And if you want to put, I can put the little 1 right there. My next bin, 60 to 65, how high does that bin go? How high does that bin go?
Isn't it 14?
14, yep. Good. My next bin goes to
8.
8. My next bin goes to
5.
my next bin goes to
1.
no. Careful, careful. Is there anything in my next bin?
Oh no.
No.
There's nothing.
So my next bin actually it's a gap and 1. What does that mean about that last height right there? What does that mean?
It could be an outlier.
It could be an outlier. It could be. It's a potential outlier. So it'll see that little gap, and it could be an outlier. Now, in this problem, I have the data, so I can mention the value of the height. What we'll see as we go on, sometimes I'm not going to give you the data, and if you're given the histogram, we need to be able to read it as well. But that's our next part. Today's about building it, okay? And so that's my histogram. That's everything right there. Boom, done. That's what I'm looking for you to do. Okay? So next part I want you to do is part B, describe the distribution. Okay? We're going to describe the distribution based on what we see in right now. This is like last night's homework now. But we also have the parts in there. Okay? And I haven't given you the summary statistics. I don't want you to find, if you want to find the summary statistics, you can do that. You can make a frequency list with this and find the 5-number summary if you wish to. But I'm really more worried about just describing the distribution based on the histogram. So the distribution of what?
of height
The distribution of heights for
students.
AP Stat students. And it turns out that in this case, if you wanted to, there was actually 28, but that's not too big for AP Stat students. So that's context. Is what?
Inches.
If you want to put like in inches right here, you can do it that way. At some point, we do have to state the word inches somewhere in my answer to get full context. That is true. But what do I talk about next? Remember, context, socks. Context socks. That's our big thing whenever you see describe the distribution and it's quantitative. So first S stands for shape. So describe the shape to me.
Asymmetrical. Asymmetrical.
It's not how we don't it is asymmetrical, correct, but that's not how we describe it.
Is it bin?
This is based on yesterday, so you wouldn't any vocabulary words you learned today you're not using. You're just like it was last night's homework, the day before's homework.
Unimodal skewing to the right.
Unimodal and skewed right. Boom. That's your shape. Unimodal and skewed right. Remember, unimodal skewed right, unimodal skewed left, unimodal symmetrical, uniform. Most all of them are going to be unimodal and one of those other ones. Now, I also want to note something here that if you think this is an outlier, you should block it from your vision when talking about the shape. So that shouldn't make your decision. If you feel that that's an outlier, you shouldn't be using that to make it. So if I block that out from my vision, it still looks skewed to the right. All right. If your answer for skewed right is because of this right here, then that means it's not skewed right. Okay. So if it's symmetrical, but then all of a sudden you see that one thing, well, that makes it skewed right. No. That just makes it an outlier. All right. Next part.
What's the outlier?
What is that?
Now it's like the next part is the outlier, right?
Correct. So what is it? So how do I write it? There is a potential high outlier of 80 inches. Okay, I'm not saying definitively that it's an outlier. And because I know the value is 80, I'm going to mention if it's 80. If I didn't have the 80, I would say there's a potential outlier between 80 and 84 inches. Between 80 and 85, if you even said that, would be okay. Next thing, center. Now the focus on tonight's homework is not to find the 5-number summary, but you can. So you may want to input this data into L1 and L2, or input the data and find the 5-number summary. But what do we have to mention here? Well, I'm going to leave it blank right now. I'm going to say the what? Since I have the data, the median is blank, and the IQR is blank. Inches. And how do I find the median? I would have to go to my graphing calculator and input this information into my graphing calculator. Now, I will also give you full credit if you just give it to me from the from my data. So if you said something like um, a typical height is between what? Is around what? What is the typical height of a AP Stat student around?
Is it between 60 and 65 inches?
Yep. So if you said between 60 and 65 inches, if you said a typical height, an average a center of a height is between 60 and 65 inches, I would give you full credit for it. What is the spread? Most all of the data is between, most all of the heights are between
55 and 85 inches.
well, that's all of the data. So when we say most of the data, I would say probably it's between 60 and 75 inches. Because there's only that one straggler on the left and there's only that one straggler on the right. So I would probably have said 60 to 70 inches. But if you said all of the data is between, and you said 85, it would, since you have the data, it should be 80. But of course, if you didn't have the data, you'd have that. Now, how do I do it with my graphing calculator? Well, stat, edit. In list one, I'm going to put the heights. Okay, so I have, what were my heights again? I had 55. Can someone name them off for me for the table? Next one was
60, 61, 60, 65, 67, 68, 71, 74,
and what?
80.
Okay. And I had 1, and then what were these ones?
3, 4, 7, 2, 3, 3, 2, 2, 1, 1.
Okay. So here's my data. I'm using my calculate 84. Okay. I can then quit back to my home screen, second quit, and I'm going to hit stat again, but go to calculate one var stats. Calculate one var stats. Oh, yeah, it doesn't have all of the options. It only has 1, 4, and 8, but all we need is 1 right now. So this one's like this is the free version of Calculate 84, which does most everything we want. Does it do all this stuff? Oh, it doesn't do any of the test. All right, well, when we get there, we'll get there. So it looks like if you want to update to all of the not unlocking stuff, it looks like you'd have to do that. But it'll do most of the stuff we need now. One var stats. My list is in list L1, but this is a frequency list. There was how many occurred for each one of them. So I hit second, then the number 2, and that will produce L2. And I hit enter. All right, so what is my median? What's the median? 63. And what's the IQR? What is the IQR?
Is this 7.5?
Yep, it's 7.5. So remember, IQR is quartile 3 minus quartile 1, Q3 minus Q1. So we would subtract those two numbers next to the median, and I get 7.5. So in my answer, I would write 63 inches for the median and 7.5 inches for my IQR. Okay. Now, your graphing calculator will allow you to check your work. All right? I don't want you to do the following until after you've made your histogram. Okay? So, the next part is completely visual and watching the video, basically. So, how do I make a histogram with my calculator now? How do I check to see if my answer, the way I've drawn it, is correct? And we'll do this multiple times. Don't worry, this won't be the only time. So if you have your data in your calculator, we've already inputted the data into my calculator. I'm gonna clear this. So stat edit, my data is in there. Okay? We want to make a histogram. To make a histogram, and this is part of your reading part, it was in there as well. You go to second y equals. Okay, second y equals. We will turn this on. If you have one of these, you can change color. Some of them don't. If you have a regular calculator, it doesn't have color. We can just skip that one. And the type is a histogram. Now, which one do you think is the histogram? Which type do you think is a histogram? Anybody?
I'm not sure. It looks way too small.
The third one?
The third one. The one.
Bar graph.
The. It's not a bar graph. The histogram. The histogram is the
I gotta give a
histogram.
second.
Don't say bar graph. We got to make sure we don't say bar graphs for histogram. It's a big thing we want to make sure we avoid. It's the third one. The histogram looking one. We hit enter right there. And my list means where my responses. My responses are in L1. But wait a minute. Did I have a frequency list in this problem? Yes or no? Was my data? Did my data have a a frequency list into it?
Yeah.
Yes. If it didn't, if you just had all of the raw data, if you just had all of the numbers and you inputted all the numbers in L1 and that's all you did, then you leave the frequency as 1. Basically, it says that every one of those numbers was 1, 1, 1, 1, 1, 1, 1, 1, 1. We don't have that, so we're going to clear that out and we're going to hit second L2. So second 2. Okay. Now, I'm going to hit zoom. And what course are we taking?
AP stats.
So we're going to select zoom. We're going to select zoom.
Stat.
Zoom stat. We're in stats, so we're going to look zoom stats. All right. Now, whoa, look, you see all this weird stuff right here. We need a there's a couple of reasons why that's happening. One of the reasons is I got something in my y equals. I need to clear that from here. And my second reasoning behind here, I think that should be it. Hey, don't tell me that this doesn't get a good histogram. I don't think, and well, that's why the purpose of this wasn't a histogram. So, yeah, this calculator does not do a good It does not actually make the histogram. I was kind of worried about that one. It should have graphed a histogram if that was the case, but this one does not, which I do not like. I'll see if I can fix the reason why. But like I said, this was just bonus right here. I did not want you to actually use the calculator to find the histogram, but that's the process that we will go into. I also got to make sure, because this is the first time I'm doing everything digitally, which means that you have to use applications. It looks like the Calculate 84 does not do a good job of doing this one. I'll look into the other ones, or I'll see if Calculate 84 will fix it. But like I said, the purpose of your homework is to do it that way. Now, if we select window, I want you to note that it has different things like there, like X min. Our X min was 50. Our X max was 85. Our X scale, which is the bin, was 5. My Y min was 0. My Y max was 14. And I went by ones. And then if I hit graph, that kind of gives me a somewhat better view. But it's not the best. And you can't even scroll around and see the views. So I am not a fan of Calculate 84's features for this one. I'll look in terms of a different one. But so you're using the data from problem 37, from 42, 32, and from chapter 5. Notice that's from chapter 5 because I just want you to use the data and also the data for 32 for just the ex-smokers. Okay, so you're going to use problems in the data from 37, 42. I will update this very shortly and state what bin width I want you to use and where I want you to start your histogram at. So I'll state the X min and the bin width that I want you to use so that it matches me. Now that means you have to go to chapter 4 and get the data for first two problems, 37 and 42, but then you have to go to chapter 5, problem 32, and you're going to do the data just for the smokers, and then you're going to do the data just for the ex-smokers. I will update this basically right after I get off with what I want the X-min and the bin width to be for each of these 4 problems. And you're making histograms, and then once you've made the histogram, I want you to describe the distributions, which means that you're going to have to input the data into your calculator to be able to view it. Now, one last trick I want to show you. One last trick before we go. Stat, edit. Okay, let's clear. Stat, edit. Stat, edit. So you have to delete every one. Oh, it's second clear all. All right, let's say we put all the numbers in there. Let's say like you input all the numbers, there's a bunch, and they're all over the place, okay? You're like, oh, how am I gonna figure out which numbers go into which bins? And it can be a little bit trickier, right? However, your calculator has a feature, okay? So what you can do is you can quit and go stat, sort A, and choose the list that you want to sort. Now this is going to sort them in ascending order. You hit enter. And now there are your numbers written in ascending order from lowest to greatest, and you can now see which ones would fit into which bins and be able to count a little bit easier. And if you go back to stat edit, typically with your graphing calculators, it would sort this list right here, but Calculate 84 does it right here, and it says here are my numbers in order from least to greatest. Questions?
Does it do that on the other calculator?
Yes, but if you do it on the other calculator app, it might not. If it doesn't spit the numbers out right here, if you go to stat edit, it typically will sort the numbers right here. Stat sort A, L1, stat. I don't know. What is that?
It just says done, but it orders.
Yeah, if it says done and you go back here, it'll reorder the numbers in the list.
Yeah.
So when you come back here, it will be reordered if you do it that way.
Okay.
Okay. And yeah, this is all funky right here. So it'll typically do the list there. I don't know why. I don't know the function features for this one right here. If I go here, I think if I do it here and I put stat sort A and I put it in front of that like this, if I do it like that, yep, it worked. That's how I would do it on this calculator. So if you want to, and if you're using Calculate 84, you need to go to the top of L1, hit enter, and then go into the very front of it and then hit the stat sort. And for example, if I want to go to descending order, it'll put them in backwards order. That's class time. It's 10:50. I don't want to hold you anything beyond that. If you have questions on how to do any of this information, please come to office hours tonight. Thank you, everybody. I'll see you tomorrow.